All right, give me questions about your homework. No questions? Good. Yes, you did. You did it yesterday in class. All right, well, let's wrap up. Let me give you. What's the bottom? Here. Thank you. The intervals. Can you go to that one more time? Like increasing, decreasing? Okay, look what they're putting on the number lines. All right, so Hannah, you said the turning points. Is there one in particular or just anyone? Or not turning points, but increasing. Let's do number 4. So to do your increasing, decreasing, you need your maxes and mins, right? Or your turning points. So I am going to, in y equals, I'm going to put this equation, 2x to the third minus 4x squared minus x. It's a cubic, so I know I can see everything I need to see. So I'm going to calculate the maximum here. Enter, enter. I got a maximum of negative 0.115059. So what y'all got? Number 4. There's no way it's completely out of ink. It's never been used. You just rounded it, that's fine. Now let me do the minimum here. (1.448) negative 3.763. I guess you can't see I'm just writing those points in there. So increasing intervals, I guess, first. So here I am increasing from negative infinity until I hit this very first turning point, that maximum, which happens here at negative 0.115. And this is kind of how I do them whenever I've got the whole graph on here, so that I don't, oh my goodness. I'm just having a hard time getting everything. Okay. And then I go to the next interval. So from here to here, I'm decreasing, right? So that is from negative 0.115 until I get to 1.448. So that's this little piece right here. And then from here on to infinity, I'm increasing, right? So I come back up to the increasing and I do the U, and I do from 1.448 to infinity. Any other questions about your homework? All right, then let's do today's. Today is the last part. We have talked about, gracious, everything. Domain range, maxes, mins, in behavior, increasing, decreasing intervals. Now we're going to talk about zeros. There they are x's. That's exactly right. Zeros is just the x-intercept or x-intercepts of the graph. I'll put the s in parentheses. We call them zeros. We sometimes call them solutions or roots. All of these are synonyms for the same thing, where I cross the x-axis. Okay? And they're very, very important. They're going to be key in a lot of things that we do. Did she tell you could have her grapes? Okay. I just want to make sure you're not just stealing her grapes there. All right, so let's graph what? I wouldn't. Let's graph one and see if we can identify the yeah. Okay. Let's do graph this for me quickly and let's see if we can find. So again, we're just on our calculators. We're not going to try to. Oh, I'm sorry. Hold on. So this is an upside down cube or quartic, right? Well, the degree is 4, and it's yeah. All right, so let's see if so there's some funny things happening here, and I'm going to talk to you about what's happening. Let's start with this 0 right here on the end, and let's see if we can calculate it, okay? So again, in the same menu, that I went to last time, which is second trace, and this time, instead of doing max or min, guess what I'm going to do? 0. But it is the same. It's the same left bound, right bound. Sometimes it's harder to see whenever it's the 0 though. So I always tell everybody, take your little spider and put it pretty close to the 0. It doesn't have to be right on it. And then scroll left a few times until you're sure that you've crossed it and hit enter. And I think we've done this before whenever we did the quadratics. Okay. Now I'm going to go right until I've crossed over again and I hit enter. And now it says, do you want me to guess? Yep, I do. So I hit enter one more time. -1, 0. So -1, 0 is one of my zeros here. Now, Rhett, you can't feel me death staring you.
Oh, wait, I gotta listen to it.
I know it is. I know. All right. I want you to notice the difference in this point right here and this point right here. What do you notice is happening? It is on the x-axis. It's still a 0. It's still on the x-axis, but do you notice that it doesn't go through the x-axis? So when you see this happen, we're going to talk about in just a minute about why that happens and when that happens. But when you see this, you cannot calculate it as a 0 because whenever I go second trace, your calculator is looking for someplace that it's below the x-axis, someplace above, and it finds a 0. So in order to find this point, what do you think I can calculate it as? Uh-huh. Say it. You were fixing to say a minimum. That's exactly right. So calculate it as a minimum instead of a 0, and let's make sure we get, remember every x-intercept is going to have a 0 y here. So as long as I do it correctly, as long as it is a 0, that'll give me 0 there. So let's calculate just like we did yesterday, left bound, right bound, enter. So did I get 0? It doesn't look like it, right? But remember what I told you, if you got an E here with a negative number that follows, but scientific notation, this is 0. Your calculator has a hard time with the pixelations and the way that it calculates zeros with actually finding it, but that's 0. If you ever see that, just assume it's 0. So this does have 1, and this would round obviously to what? 1. So this has a 0 at 1, 0. See if, so I've got negative 1, 0, 1, 0. See if you can calculate that last one. Yeah, you can do it. Negative 3. Notice how my calculator did it again with the E. That's okay. That's just a calculator error, I guess. So 3, 0. Yeah. Questions about finding zeros? Are y'all okay? Pretty straightforward, just like yesterday. Yes, ma'am. Yes, that's correct. 3, 0. 3, 0. Armando, 3, 0. All right. That's zeros. So algebraically, how do we find zeros? Because you've been doing it before, you just didn't, I don't know that you called it that. In other words, if I had something like, that's a 3. If I asked you to find the zeros of that, what would you do? Equal it to 0. Yeah. So we will get into factoring polynomials extensively right now, what you'll do right now to find them. It will be basic. We'll take out GCFs, and then we'll factor quadratics the way you already know how. In other words, here, take out an x, it leaves me with x squared minus 2x minus 15. And now can I factor what's in parentheses? Okay. That's right. Because, and if you guys haven't, I don't usually show you the shortcut until we get back to this point because I don't want you shortcutting everything when you can't. If the leading coefficient is a 1, you don't even have to slash it. The factors that you get whenever you told me it was negative 5 and 3, you can just go ahead and break this down as x minus 5, x plus 3. But that only works when there's no number in front. For real.
You need to do all that work.
Because it doesn't always work. It only works when the leading coefficient is 1. You told me, I said what multiplies to negative 15 adds to negative 2. It's negative 5 and 3. You can just go straight into putting into the parentheses here without actually doing x squared minus 5x plus 3x minus 15 and slashing. And the reason you can do that is because the leading coefficient is 1. But only when the leading coefficient is 1. Never. Lenny's going to take it Thursday with class. All right. Where was I? Okay, factoring. Y'all okay on that factor? Rhett? Why is it so important?
It's like you meaning. It's like meaning it's celebrity stuff.
He didn't. They're just talking about it. What if? And it's so important. All right. So what are the zeros of this function?
5.
That's right. Remember how we set each piece to 0? We've been doing it. That's exactly right. We've been doing. That's why I'm kind of blowing through this pretty fast. So 0, 0, 5, 0, and -3. Yes. So I show you this for a particular reason. And the reason is, what if I had something, y'all got that? What if I had something that looked like this? What are the zeros? -1 and 5. What about this, though? What about that, too? So it's right. It's what we call a repeated solution, okay? And this is very, very important because I could write this as x plus 1, x plus 1, x minus 5. So that -1 is happening twice. Do we all agree with that? What we do is we call that a multiplicity. Multiplicity tells me how many times it happens. So I say this has a multiplicity of 2 because it happens twice. Does that make sense? Your total number of solutions, or zeros, should equal the degree of the polynomial. So if I have a degree of 3, if I have a cubic, I should get 3 answers. But those 3 answers include repeated solutions. So if you look, this one's happening twice, so there's 2 solutions. This one's only happening once. Does that make sense? Okay. Why is this important? This is important because multiplicity tells us a lot about the graph, okay? Y'all got that? Oh, okay. Well, the degree of this one would be 3. If you FOILed this out and multiplied it all the way out, you would end up with a cubic of 3. And I know that, too, based on the zeros, because this happens twice. This one happens once, so it's got to be a degree of 3. Now, what does multiplicity tell us? And I promise I'm almost done. Multiplicity tells us what the 0 looks like. Remember how we had that graph and it looked something like this, right? This is what we call a bounce. And bounces happen when I have an even multiplicity, right? Bounce, okay? And bounces happen when your multiplicity is even. 2, 4, 6, 8. We appreciate it. I'm just kidding. But any even number multiplicity, y'all didn't even.
I laughed.
Thank you, Armando. Thank you. Inside. But when the multiplicity is even, it bounces. Okay, so it is a 0. It does sit on the x-axis, but it literally touches it and whoop, it goes back up, or whoop, goes back down. Okay, y'all okay there? So that means that these are what we call through, or what I call through. They go straight through the x-axis, and those happen when the multiplicity is odd. 1, 3, 5, 7. Yeah, no, don't work on that one, buddy. Why?
That's an insult.
Is it? What does it mean? Why? Y'all are an odd generation. All right, let me show you an example and I'll be done. This wasn't necessarily this one. I jumped off because I'm spastic. This was just a separate example. The one circled in pink are odd multiplicity. The one in green is even. So if I'm over here, though, what's happening is on this one, and graph it and look at it. Let's do that. So let's go back to the example that I had. And put it in just like what? It should, okay, this one. Did you put that one in? Put that one in and let's look at it. What did he say? Something ugly? Worse than Buddy. Buddy is not bad. Come on. Oh my gosh. The language I have heard come out of your mouth and you are offended by Buddy? That's where he draws the line. X plus 1 squared. X plus 1 squared. I don't know where that even came from. X. Oh, I don't know. Yep. So if what I have thought about with multiplicity is correct, then whenever I hit -1, I should bounce. Whenever I hit 5, I should go through. So let's see if that's what happens. It doesn't matter. Look, -1, it bounces. 5, it goes straight through. Multiplicity. Y'all okay? Yeah. Let me just show you how to use this, and then I will give you your work and be done. Dang, we're early today. All right, buddy. Little buddy. But you put it in order. What's the first 0 here? I don't even want you to graph it. I want you to look at the equation. -7. So says, who said that? Armando or Caleb? -7. What's the multiplicity? Why? Why? How did you know it's -7? This first factor. If you set that equal to 0, right? Multiplicity is 2, so what does that mean? It bounces. What's the next 0? It's -1/2. -1/2. I got to subtract the 1 and divide by 2. What is the multiplicity of -1/2? 1. What does that mean it does to the graph? 3. What's the last 0? Good job. Multiplicity? 3. What does that mean on the graph, Rhett? Through. Rhett, you have been so bad today. Poor thing just got his Fortnite back.